This is AQA Statistics, Continuous Random Variables 5. This video is about the median of the exponential distribution. We can use the cumulative distribution function to find the median of the exponential probability distribution. We can also use it to find quartiles and other percentiles, such as the 90th percentile, things of that sort. Now, here's a reminder that the CDF is a cumulative probability. And here's the formula for the CDF, which, when we plot it, comes to a nice graph like this. Here's t on the horizontal axis, and then we've got f of t up here on the vertical axis. Now, in order to find the median from a graph like this, we would run across at the 50% point until we meet the graph, and then drop down here to the t-axis, and the value that we reach on this axis then is going to be our median value. So to find the median then, we're going to say that f of q2, which is to say 1 minus e to the minus lambda q2, will be 0.5. Please pause the video to read the example and to calculate the median time interval. The formula that we looked at on the previous page then, here's our formula for the CDF, and we're going to allow that at the median value of q2 to be 0.5. We can rearrange this a little bit, and we've got e to the power minus lambda q2 is going to be equal to 0.5. If we then take logs, we finish up with minus lambda q2 is equal to ln of 0.5. In this case, lambda is 0.5. That is the rate of arrivals to the accident and emergency department. So substituting in, what we can now see is that the quartile 2 is going to be minus ln of 0.5 divided by 0.5. Calculating this, rounding to 3 decimal places, we find that the median is 1.386 minutes. Please pause for a moment to read the example and to work out the interquartile range. Now, the first equation that we need to solve is this one here. So here what we're looking at is for the lower quartile then, the CDF at the lower quartile is going to be 1 minus e to the minus lambda q1, and that will be equal to 0.25. Rearranging, just simply subtracting the 0.25 from the 1 and adding this term here, the exponential term, to both sides, we get this equation here to solve to find the lower quartile. The upper quartile, a similar equation, but this time entering 0.75 here together with the third quartile, and then we finish up with this equation here to solve to find the upper quartile. We don't actually need the quartiles in this case. So here are the two equations that we've derived for the upper and lower quartile, and just remembering up here that lambda is equal to 0.5. So let's just write that out, including the correct value of lambda. So we've got e to the minus 0.5 q1 is equal to 0.75, and e to the minus 0.5 q3 is equal to 0.25. If we now take logs, we've got minus 0.5 q1 is equal to ln of 0.75, and we've got minus 0.5 of Q3 is equal to ln of 0.25. Now remember, what we're looking for is Q3 minus Q1. So how we're going to get to that then, Q3 minus Q1, that's going to be minus ln of 0.25 divided by 0.5. And then we're going to subtract Q1 from that, which effectively is going to mean that we're going to add it, since it's already negative up here. So we've got plus ln of 0.75 over 0.5. Now, if we put that into our calculator, then we finish up with something approximately 2.20 for the interquartile range. That completes this video on the median of the exponential distribution. The next video is on deriving the formulae for the mean and variance of the exponential distribution.